Okay, let's get started. Welcome back to the software testing and the quality assurance class. Okay. If you looked at our tentative schedule and the list of topics, it appears that we are a little bit behind schedule, but actually we're not that much behind schedule because we did spend a lot more time on chapter 3 and which really we covered more than chapter 3. We covered some of the things from chapter 13 through 16 and also something from 6 and 7. Okay, so what I can do next is really, if you look at our schedule there, appears to be we are 1 week behind the schedule, more than 1 week behind schedule, but we are not. Okay, I'll be briefly talking about things from chapter 4, 5, 6, and 7, and then we will move on to 8. Okay, because we actually did cover quite a bit of the things that's in those chapters. And right before the last week's class, we did go through a few of the slides of chapter 5, and so we kind of, I don't want to spend too much time on those things, and they are fairly straightforward, and we covered them in high level, and so you can read the textbook yourselves and get some more details about those topics. Okay, so another thing is we had the first homework due earlier this week, and for the distance student it's due today. And so you should have submitted your homework, if not by now, for the distance student by tonight. Okay, and I have talked with your grader, and he's going to try to finish grading everything within 1 week for every of the homework assignment. So that's what we're trying to do. So before next class, you should expect your graded homework number 1 back with some comments. Okay, or maybe if you did it perfectly, you just get a score. If you have some places wrong, and you will probably get some comments from your grader. Okay, and the next thing that is coming up is your project proposal. Okay, which is due next week. Okay, early next week, and if you haven't really started thinking seriously about your project, you should now, and try to prepare your proposal. I got asked a couple of times about the length of the proposal and the thing. The main thing is really you need to cover whatever I mentioned here in the project proposal. What are the things that I expect you to cover? Okay, and then it's about 3 to 5 pages, but if you are on the lower end, it's okay. About 3 pages is okay. But if it's a 1-page document, it's probably not going to cover all the points. Okay, and I don't expect to see anything that's much longer than 5 pages. Okay, so if you are a little bit longer than 5 pages, that's okay. But try not to go too much longer than 5 pages. Okay, and the project proposal, I'll be grading them. I'll be giving you feedback. Okay, the homework will be graded by the grader. Okay, and so that's a little bit about the things coming up next. Okay, and after your project, I'll probably post the next homework assignment. I don't want to have too many of the things concurrently. So because your project proposal will be due next week, I'm not going to post a homework assignment this week. Okay, but most likely next week I'll be posting a homework assignment, which will be due probably a week after next. Okay. And any other questions so far? Okay. So let me move on to try to wrap up the rest of the material we have left from part 1 and the first couple of chapters from part 2. Okay, so the chapter 4 is about quality assurance in context. So we spent a lot of time, and actually more than one class, to talk about the different QA alternatives. Okay, and we really looking at their quality as a part of something that we really associated with defect. High quality means no defect or low number of defects, and then we were looking at if that's our definition of quality, then what do we do with quality assurance is really tightly linked to what we do with defect. Okay, we can do defect prevention, we can do defect removal, we can do defect some kind of defect containment. Okay, and so those are the three major strategies, and then we looked at some of the major techniques, the QA techniques that applies to those fall into one of those strategies, and sometimes they may fall into a couple of the things, like for example, most of the cases fall into one of those major strategies, like testing and inspection. They are both doing the defect removal, but they do it differently. But when you look at the formal method, and actually it's a kind of a strand of two things, because the formal verification part is really more helping us with defect prevention. Formal verification part is a kind of similar to testing and inspection, but focus on the correctness of the program, okay, instead of the incorrectness. So you flip the thing around, but still focusing on whether something is there or is not there, okay. And so we looked at those as the major different kind of categories and the major techniques for doing the quality assurance. So then there are some kind of nitty-gritty details about, okay, you do that, you need to keep track of the defect information. Okay, so we will be looking at a little bit about defect handling, and then all those QA process, different QA activities, how they fit into the overall software development and maintenance process. Okay, and also another thing that we often see in software engineering literature is the V and V perspective, verification and the validation perspective. We have this kind of defect-centered view. We look at defect prevention, defect removal, and the defect containment. How those views compare with the V and V view. So we want to take a look of that so that you can put whatever we talked about in terms of quality assurance activities, quality assurance techniques into kind of a broad perspective, and you can relate this to other software engineering literature and relate to what people do in industry as well. Okay, so in terms of the context, we try to look at first some of the defect handling. Okay, the basic thing with defect handling is that we need to keep track of them so that we know what's the status and whether something has been done and they have been resolved successfully. Okay, so basically we need to look at the first thing is look at what's the status now. It's a new, just opened. It's worked on. It is fixed, and or it's need to be refixed or what. Okay, so we need to kind of keep track of them so that make sure each of the valid defect will be somewhat dealt with before we release the product. Okay, most likely we will deal with those defects by fixing them, but sometimes if we have a limited amount of time, a limited amount of money, we might decide to forego the fixing of some not so critical defects. Okay, so because there are some of the defects that we just simply we don't have time to fix everything, and say, okay, they are in some of the things that's not so critically important, and we can maybe there's some workaround about this defect. So let's just leave it, and then we can work on it later. That's a possibility. Okay, but if it's deferred to further releases, then there must be fully justified, and people need to agree on it and need to be aware of it. Okay, so it's not something that we just wave our hand and say let's go, that's it. But we still need to keep track of them, and then need to have some kind of a long-term strategy to deal with it in the later phases, okay, or later releases, okay. And we generally need to perform some kind of analysis. One of the basic analysis is the so-called causal analysis. What caused this thing? What's the reason for this? Okay, so typically we are already performing some of the things with some of the quality assurance activities. For example, with testing, you observe failures and you try to fix the faults. How do you relate from failures back to faults? That's through some kind of a causal analysis. Okay, so you say, oh, I didn't perform causal analysis. I know this fault is going to is related to this, and so I fix this fault. Well, you did implicit causal analysis because you know by fixing this fault, this failure will go away. That's the causal analysis. Okay, so you use the fault causal analysis without formally performing it. Okay, so oftentimes those causal analyses can be based on your knowledge, your expertise. Okay, and generally, as I mentioned, the resolution typically involves a defect removal, but sometimes can be a deferral of a defect, but you need to know. But overall improvement is really you want to break the causal chain from errors to faults to failures. Okay, and so when a lot of times that we are not just performing the causal analysis, we're also performing some kind of statistical analysis, not just individual defects, but defects as a collection, as a whole. Okay, and look at the defect distribution, look at the overall causes, look at the various other things related to defect, and then try to find something and some way to deal with those problems and improve the quality. We'll get to much more about that later on, and actually towards the end of the semester, part 4 of our textbook is actually about all kinds of different analysis and to support the software quality engineering process. Okay, and so one of the most important defect analysis that we perform related to quality is defect analysis. So we will be spending a little bit of time on that. And this is kind of also related to our course project, okay? Because when you do your project, okay, then you will hopefully find some defects, okay, during testing, okay? So when you perform the analysis, I expect you to perform the analysis at 2 levels. So one is at the individual defect level, okay? Look at what caused this defect and how to fix this defect. And so individual defect level, you need to perform some follow-up and analysis, okay? And then you should also perform some kind of analysis collectively about all the defects you found, okay? And so in this case, for example, you use the 2 testing techniques. Technique A found 15 defects. Okay, technique B found maybe 2 defects. Okay, and then you spend about the same amount of hours on A and B, and then in this case, A appears to be more effective in detecting defects than B because they spend the same amount of time. You detect 15. In the other technique, you spend the same amount of time, you only detect 2. So those kind of analysis, and then you may also perform some analysis about the defect distribution, the defect trend, and various things like that. So for that, of course, before the project report due, we probably haven't covered that chapter yet. So what I'm expecting you to do is, for the graduate student, I expect you to as part of your course project, do a little bit of independent study, reading ahead a little bit. I think it's chapter 19, okay, and then read it a little bit, and then try to perform some of that analysis as part of your overall project, okay. So I'll talk a little bit more about that as we go near the kind of deadline for the project report. Okay, so again, this is another difference between the requirement for the graduate student and the undergraduate student. For the undergraduate student, I don't really require you to do as much independent learning study as for the graduate student. So if you leave the result analysis at a fairly kind of basic level, that's okay for the undergraduate student project. Okay, but for the graduate student, I expect you to do a little bit analysis of the problems, results that you obtained from your course project. Okay. And so in terms of the overall defect tracking, you need to track the defect, and you need to take some measurement about the defect. Okay. So you typically, in parallel with the handling of the defects, that you will be taking some measurement. Okay. So here are some of the typical measurement we take about defect. So for example, where was it injected? Where was it found? Actually, those two questions are quite different. When you say where was it found, it's actually not so difficult, because if you found it through where and when you found it, you through inspections, through testing. When you did the inspection of this module, this is when and where you found it. Okay, when you did the testing, you tested this module or you tested this function, this is where and when you found it. Okay. But say, where was it injected? Where and when was it injected? It might be a much trickier question, because this one can be from the last part of the coding process, or maybe it's a design fault, or maybe it could be, worst case, is a kind of some requirement problem, okay, that didn't get caught in the first place, okay, and so now you need to really work on this. Okay, so so when you look at this, where it's found, you don't really need to perform much deeper analysis. But where it was injected, you have to perform some kind of causal analysis and a deeper analysis. Okay, what type is it? Okay, and of course, when you say what type is it, what do you mean by type? And so sometimes people say, oh, type of the problem, the system crashed. Okay, that's a type. Okay, and sometimes we say, oh, it's an algorithm problem. That's a type. So when you talk about that, that's actually you are talking about different meanings of the type there. When I say it's a system crashes and versus a system not responsive, or a system give you the wrong answer, that's really looking at the failures. What's the type of the failure? Okay. And when you say it's an algorithm problem, a data problem, or it's an interface problem or something, it's more of like a fault problem, okay? Because you have the wrong algorithm, you have the wrong data structure, you have the wrong control structure, you had the wrong improper interface between the different modules. So that's more like a fault type, okay? So as you can see that when you measure the defect, that you can measure it from the fault view, measure it from the failure view, and you can consider various different attributes that are associated with the defect. Okay, so later on, as we will move on, we'll be talking a little bit about the ODC, orthogonal defect classification. That's also in chapter 19. Okay, and so again, that part I think is very important for people to at least get exposure to, but I probably won't expect you to perform a formal ODC analysis for your project, because for your project it's probably going to be small, and then the ODC analysis may not be as meaningful as for large industrial projects. Okay. Another thing about the defect measurement and the tracking is that really you will be using those defect measurement data in the process to make decisions and to do things. And actually we did look at this actually here. I'm glad that we talked about this one already. And so we need to use those measurement and the result for decision making and for making adjustment. Okay, So if you are using your measurement data, defect metrics, defect measurement data, and the result for decision making and for some of the adjustment, then you need to make sure that whatever your interpretation of the defect need to be consistent and up to date. Okay, so you can make logical, consistent, and timely decisions. Okay, so for either the product release or you need to make some adjustment. Particularly with the adjustment, you need to have timely data. Okay, so that you can make adjustment. Okay, so that's why we emphasize here that you need to have a consistent interpretation and have timely defect reporting so that you can use them to do various things. So those various things, what we do is that really we use the defect measurement, and oftentimes with some other measurement, we can build some models, can predict whether something is going well or not going well. Okay, for example, one of the things that we will be seeing later on and use more often is something like this. Okay, so for example, you can measure the number of defects. Okay, and you can measure the time to observe those defects or observe those failures. So in this case, I may have a time, okay, some kind of usage-based time, and I have some kind of usage time here, and I have a cumulative defect or failures, or failure observations. Okay. And then I can plot them, say, oh, okay, at here I have not observed anything yet. I observe this, this, and this, maybe this, maybe this, maybe this. Because it's a cumulative, it's supposedly not going down, right? If you have a consistent interpretation, okay? And then you say, oh, okay, I can see this one is start like this, and we are discovering a lot of defects. And then as we continue with our testing, we are not discovering as many defects, and because really we fixed those defects, and the product is getting more solid and better quality, and getting better, okay, in quality. So that's just the general trend. If that's the general trend, you say, okay, based on some assumptions, I can fit some curve to it. Okay, so for example, I can fit this curve to it. Okay. This curve may be based on various assumptions and derivations. So for example, one of the curves, such curve is, say, the number of expected defect is something like this one, capital N of 1 minus e to the minus bt power. Let's use a. I don't want to use the same letter again. Okay, so you might be fitting a curve like this to there. Okay, so what you did there is that, well, you did, in this case, we had a reliability model. Okay, so look at the overall failure arrival and look at the trend. Then, so the expected number of failure observations is following this function, for example. Okay, we have some discussion about that as the last chapter of the book, chapter 22. And we probably will not go into details there, but as I mentioned to you before, as a follow-up to this course, actually next semester I'm going to teach this 83 CSE 8317. That's SRE, Software Reliability Engineering, and Software Safety Engineering. Okay, so that's the reliability. And here is the safety. So we'll be teaching that class, and so if you want to learn more about the reliability engineering, safety engineering, and actually it's a very nice follow-up to this class on quality assurance and testing, okay, because it really fits the other half of the quality assurance where after you do those things, and then you need to make assessment, make prediction, and use the result to do the control. That is where things get applied. Okay, so it's a really, really nice companion and follow-up to that course. So I hope that to see some of the familiar faces in the next semester there. Okay, so going back to the defect measurement and the things is that we are trying to take those measurements so we can use this in those kind of models. When you use it in those kind of models, you say, okay, now we are here. We can, if we have this function fitted, so we can extend this function into the future. So that gives us some kind of power to predict into the future or forecast into the future. Okay, and then that can help us to say how reliable this product is. Is it ready for product release? If it's not, how much longer do I need to get to that level? Because I do have a curve now, I can do various calculations with the curve. Okay, so we can use that back to use some of the get some quality assessment, prediction into the future, and help us to do the improvement. If it is, for example, this part is not reliable enough, but the other part is more reliable, so maybe you should focus more on this part to make the whole system more reliable. Okay, so you will be performing all kinds of different analysis in doing that, and so defect analysis will be an important part, an important basis for doing all kinds of analysis. Okay. What comes next is a little bit about the QA activities, how they fit into the overall development activities. Okay, the basic understanding is that kind of assumption is that you know a little bit about your software processes or the major activities. So let's say if you have a waterfall process, okay, what are the kind of activities spread out to be? Okay, so this is in the central part here is the waterfall process. You have the requirements specification, design, coding, testing, release, and the software support. So that's the overall waterfall process. So you move on, you finish one phase and then move on to the next phase, and then move on to the next phase, and you may have some rework and feedback when you do the phase transition, but generally it's a somewhat staged approach. Well, in this waterfall process, we talked about all those kind of quality assurance activities. Where are those activities performed? The short answer is they are performed all over. Some of the activities may be concentrated on some of the phases, but generally there will be some QA activities all over the places. Okay. So for example, testing itself is one of the major phase of the development cycle, okay, in the waterfall process. So it is itself is a focus on QA. Okay, so that's a QA focused phase. You say, oh, what about coding, design, requirements, and release and support? There are QA activities associated with that too. For example, we mentioned about inspection. Inspection, you can apply it to anything that you can lay your hands on. Okay, so anything that's tangible, you can inspect. Okay, so consequently, one of the most common kind of inspection that's kind of something similar along the line of inspection is you have some kind of review from transition, when you do the transition from one phase to another phase. Okay, so you have a kind of a requirement specification review, have some kind of design review here, some kind of code review here, some kind of a test readiness, product readiness review here. So when you do those reviews, they are kind of like inspections, right? Reviews and inspections. And then we looking at upfront, we try to also focus on some of the defect prevention, okay? And in the middle part, when a lot of things were committed to the product already, we try to focus on the defect removal, okay? And when the product is already in the field, then we focus on operational support for some kind of defect containment. Okay. Of course, many of those defect containment activities and the mechanisms need to be designed and implemented and tested before. Okay. So you say, okay, I have the MVP in working in the thing that will be working from, but you must have designed the MVP into your system, implemented it, and tested it, and then you use it in the in the field operation. Okay, so that's the basic thing about QA process and where they fit in. Okay, and there are variations to non-waterfall models, but with the non-waterfall models, then QA will still be all over the place. Okay, but with probably somewhat different focus. For example, if you have a spiral model, okay, so you go into the spirals so that it's a kind of iterative with a risk-driven model. So you look at where's the major risk area, and then you look at its requirement design, testing, implementation, and then move on to the next area, and so on. So you can think of their you can think of each of the iteration as a mini waterfall, and then all kinds of activities can fit into those kind of things. Okay, and then you can look at the other models, iterative, incremental, extreme programming kind of processes. Actually, in extreme programming, they emphasize the test-driven development, TDD. So they kind of testing plays an even more important role in those other processes. Okay, and QA also play an important role in the maintenance process, not in just the overall development process. But you have to look at the maintenance process. Okay, in the maintenance process, you really need to focus on the defect handling and the defect. In the operational phase, you really look at okay, I want to minimize the disruption. So if you do have some kind of ways of tolerate the faults or minimize the impact of the failures, then it will be really useful. Okay, and then if you want to, when we're talking about the maintenance activities, typically they can be divided into 3 categories. Okay, the corrective maintenance, something wrong, you need to correct them. That's a corrective maintenance. Okay, and that one is a very closely related to the customer usage and sometimes maybe in-field related testing. Okay, and then you can correct the problem, have a refresh, and sometimes that will lead to a new release or new version of the product. Okay, and sometimes you have the so-called adaptive maintenance. Okay, so you are originally having a system for this kind of a platform. Now you say, okay, I want to have this one working not only for the PC environment, but also for Macs and for mobile environment. So I adapt this product or this application to this new environment. Okay, and sometimes is that I try to provide more functions, better functions, or something that's called a perfective maintenance. Okay, in each of those things, quality assurance will play an important role. Especially when you look at the corrective maintenance, that's directly related to the quality assurance. You try to make sure that it's working, correcting the problems that you had before. Okay, with adaptive and perfective maintenance, of course, you need to look at the match between your thing and the new expectation and the new environment. Okay, so new expectation, new environment can all be quantified with your quality metrics, and then you try to manage with those as well. Okay, and so that's the actually I want to there's a distribution of the things. Yeah, later on. Okay, there's also another kind of a concept that we mentioned about, but we didn't go into too much details yet. It's about the validation versus the verification as the QA activity classification. So essentially, what we are looking at thing with V&V that's often used in the software engineering community is verification and validation. Validation is with respect to your requirement. Okay, what is it doing? Okay, and you're trying to say whether it's doing this thing, doing this kind of thing. So that's really appropriate, whether it's are you doing the right things or not, okay? And the verification is really look at the specification and design, and is it correct? Are you doing it right or not, okay? So in our view, we will look at the correctness view. We say, oh, we just have this verification view. No, we also have the validation view because we want to see whether something is required is missing. That's a problem too, right? So that's considered to be incorrect as well. Okay, if something is required but it's missing, it's considered as a defect as well. Okay, and so our view of defect covers both the verification and the validation view. But if you look at the overall process, okay, the verification and validation, they are the different focus over the time. Okay, so for example, that this is the so-called V model. Easy way of thinking of V model is actually thinking of it as the waterfall model, bend up. Okay, so you have the waterfall here. If you have this waterfall model here, in the middle, you bend it over. Okay, so the going down and then bend it up. That's the V model. Okay, but with the V model, essentially what we are trying to emphasize is that we kind of emphasize a lot of correspondence between the implementation activities and the verification and validation activities. Okay, so on the left part is mostly implementation related. So you get the requirement right, you get the specification, you get the high-level design, low-level design, then you get the code. Okay, on the right part, you are verify this or validate this things. Okay, so with the unit testing, you basically verifying your code is correct. Okay, with the component testing, you basically verify your low-level design for that component is implemented correctly. Okay, with the integration testing, you basically verify the high-level design and all those different pieces are fitting together. They really fitting together correctly. Okay, and with your system testing, you really looking at your system is performing the function you want and performing it correctly. So you are doing both verification and validation for your whole system. Okay, but when you look at the overall operational usage, that is basically the customers will be using your system. Basically, that validates your system. Your system is validated or not like that. So that's kind of you can say verification and validation activities is also spread out all over the development process. Okay, but then you say, oh, okay, those verification and validation activities, and then we have those defect-centered view of defect prevention, defect removal, and defect containment. How do they kind of match up with each other? We do have a table to kind of match them up, but they're not terribly important. It's good to know that some of the things can match up fairly well, but some of the things may not match up so well. But for example, with defect prevention is not directly related to either validation or verification. Because when you look at the verification and validation, you assume something is there. You try to validate it or you try to verify it. Before it's there, it's somewhat immaterial to talk about the verification or validation. Okay, so the defect prevention, basically you use them somewhat kind of indirectly. But when you have some of the things that's already there with the defect reduction and the defect containment, then you do have a very nice kind of mapping between our QA activities and the verification and validation view. For example, this picture here gives us some mapping about the testing, different testing. Some of the testing is doing the verification, some of the testing is doing validation. Okay, and similarly, inspection. Some of the inspection may be focused on the verification aspect. Some of the inspection focus on the validation aspect. Okay, so for example, if you do the requirement review, well, that's definitely more related to validation than verification. If you do the code review, okay, if you focus on the individual code, it is probably more related to the verifications, okay. But if you look at some kind of a scenario guided review, then you could be looking at the verification, could be looking at the validation, because you may be looking at this usage scenarios, and can I inspect the product against this usage scenario? Then that usage scenario is typically represent the customer usage, and then you will probably doing some level of verification with the validation in mind as well. Okay, so the mapping is not that simple, but generally we can map them into, if something is there already, we can map them into either the verification view or validation view. Okay, so you can look at the details a little bit on your own. So that's essentially the overall context of the QA activities in the development process, in defect handling, and then the relation between our classification and the V and V views of quality assurance. Okay, so I'll spend the next 10-15 minutes to try to also wrap up what we have left from this chapter 5. We looked at the SQE process already. So what I want to do a little bit is, you see, we look at the SQE process is we have the QA, okay, and the QA activities, and then we need some kind of management of the QA activities and some kind of planning activities and management of the QA activities. So to support that, we provide this framework to do the whole thing. We call this SQE, software quality engineering. Okay, so it has this process we looked at already, and which basically surround the QA activities with various other supporting activities and the supporting mechanisms for us to do a good job on QA. Okay, so we talked about quality planning. We need to set the goal. We need to select what specific set of QA activities to perform. And we also need to select some strategy and metrics that we will be using to monitor those QA activities. Okay, and then the monitoring will be taking the measurement data from here and then perform some kind of analysis modeling, such as the reliability model we just looked at maybe 20 minutes, 30 minutes ago. Okay, and then try to use that for our decision making. Whether if the goal has been met, we can go on to the next step. If it has not, we make some adjustment. Okay, so that's the basic mechanism. Okay, and so you can think of this SQE as some kind of implementation of the quality improvement paradigm. Okay, QIP is something that was initially proposed by Professor Vic Basili at the University of Maryland. Okay, and he was working with the NASA Software Engineering Laboratory. That's a joint venture between University of Maryland, NASA Goddard Space Flight Center, and the Computer Sciences Corporation, which is the contractor, software contractor for NASA. Okay, and so they were looking at quality improvement paradigms, support for that, and so on. So basically, the idea is that if you want to improve the quality, then you need to understand where you are. Okay, and so that's kind of always like some people say that where should I go? Okay, it depends on where do you want to get to. Okay, and so you have to look at where you are and where you want to get to, so determine where which way to take and how to do it. So before you go somewhere, you have to know where you are and where you will try to get to, and then so you need some kind of current location and the destination. Okay, and so you have a starting point and a destination point, and so you have to understand what's your starting point. Okay, and then you try to look at you try to get some destination, and you have some strategy to do it. you need to make sure that the strategy works, and then you can go ahead. Okay, so you explore first, then you commit. Okay, so basically that's quite a common sense. And to support that, then they had also the so-called GQM, so goals, questions, metrics. So in order to get from where you are to where you want to go and your change impact, you need to look at what's your overall goal and what are the questions you can ask about those goals, and what are the particular metrics you can use, and then to measure your achievement or progress towards that goal. Okay, and then you can design your things to make sure that you will be making this so-called quantifiable improvement. Okay, and there are also some support for that is really looking at the providing some experience base to support that. Okay, so that's a general framework. So we can consider that our SQE as a kind of customize QIP into just focus on the quality part. Okay, and so we have the overall goal setting, planning, tracking mechanism, and then some kind of feedback and adjustment mechanism. So not only help us control the project, but also make adjustments to optimize the outcome. Okay, so we did talk about some of the planning, which involves the goal setting, and when you try to set the goals, really you're looking at what are the things that's important to you. So we talked about the quality attributes. For example, if you are working on something that the people really rely on, then reliability is a very important aspect. Okay, so you probably should state your quality goals in terms of reliability. But if your system is supposed to be operating continuously, only reliability goals will probably not be enough, because whenever you can think of two systems, one that goes down every 6 months, okay, another one goes down every week. Okay, the one goes down every 6 months, it takes 6 months to repair. Okay, and then if you give this to someone, on the average, they only can expect 50% of the time this system is available, because it takes a long time to repair this. But it can last 6 months. That's good reliability, but it's not a good repair. No easy repair. Just imagine your one goes down every week, on the average, but it takes maybe just a couple of seconds to repair and get it running again. Then if you give this to someone, they are supposed to be running something continuously, then this one with the lower reliability is actually better, because it had a better repairability, and so in terms of the overall availability, when it's available at any given time, it's better. Okay, so you have to look at what is the most important to your customers, and then set a goal in terms of that thing. Okay, for example, in the first case, you say it takes forever to repair. Maybe you don't care. Maybe you send it to a satellite, and then it goes out of the solar system. Okay, so in that case, you want to maximize the reliability. You don't care about the repair. Maybe take an infinite long time to repair. I don't care. I just send it out. It's just a one-shot deal. I won't have a chance to repair anyway. Okay, so in that case, I just try to maximize the reliability and without considering repair availability at all. Okay, but in the normal case that you say, for example, you have a telecommunication switch and things like that, you're supposed to if something goes wrong, you need to repair it and make sure it's working again. And then in that case, availability is more important. Okay, if you have a mass market, then probably usability is very important. Okay, think of the things that we use the web every day, we use mobile devices every day. Usability is critically important. Okay, because so many people are using it. You cannot expect that everybody is an expert on using things. So you cannot expect people spend 2 months learning about using your iPhone before they can use the iPhone. Then your iPhone will not be successful. Okay, so you have to identify what's important to them, and then look at what's the metric for them for that, and then you can track and your expectation, your progress towards that goal with that quantified metric. Okay? And you need to identify the attributes and doing the things and doing the reliability and the other metrics and so whatever is important to you. And we talk more about that towards the end of the semester also. Okay, and when you look at the quality assurance strategies, the main thing there is that you have to understand that different strategies has different strengths and weakness. Okay, so for example, compare inspection with testing. Inspection can be applied early and almost everywhere. Testing cannot. So you say, oh, I always use inspection, no testing. Well, wrong. Because inspection will be hard to deal with the dynamic problems. Okay, lots of kind of intricate things you can only discover in testing. Okay, so typically you need a kind of a combination of a different testing and different inspection techniques. Okay, so you have to look at what's the individual strengths and weakness, and then try to come up with a comprehensive strategy. Okay, so when we finish up with the testing and with some other quality assurance activities, we will do a grand comparison of all the major the techniques, and that will help us understand the strengths and weaknesses of each of the things. And then typically for planning, then we need to look at a kind of comprehensive collection of QA techniques, okay, not just one. Okay, and we also need to plan for the measurement and feedback, so we need to track what goal we are trying to move against. Okay, and so we can track the progress as well. Okay, and in terms of analysis and feedback, the mainly is really you want to analyze whatever you collect from the QA activities, and oftentimes which is tied to the overall development activity, and then try to make decisions, make assessment, make decisions, make predictions, make some adjustment and improvement to it. Okay, so one example of that is this one. Again, we looked at this. So we look at this is the time here. Is this a product ready or not? Okay, if this basically here, the slope of this curve signals how reliable it is, right? The flatter it is, more reliable. It takes much longer to see the next failure. Okay, so is this good enough? Okay, so you have an assessment here, and then you use that assessment to make a decision. If this is good enough, I can release the product. If it's not, I continue to win. I can extend this curve further. So I have the curve, so that will give me some information about how much longer do I need to reach that goal. Okay, and if it's not good enough, and I can do maybe some additional analysis, find out where it is really bad, where it's good, and I can focus on the bad part, so make sure it's as good as the good part. Okay, and then that can help us making the improvement. So that's the overall analysis and improvement part. Okay, and so we need to do all those things. Okay, and all those things need to be fit into the software engineering process as well. So similar to what we did in the previous chapter, we look at the QA activities, how they fit into the overall process. We can look at how they fit into the process as QE activities, the planning part, the assurance, quality assurance part, look at the assessment and improvement part, how they fit into the things. So planning always comes up very early, okay, and somewhat persistent, but kind of winding down after a while. Okay, with quality assurance, they probably have a different profile. We're probably doing a lot more quality assurance activities towards the end of the product release, their development. Okay, and the analysis and improvement will be you have to get the data to perform the analysis and improvement, so it's lagging behind a little bit. Okay, so generally, if you look at over the different phases and over time, it's probably going to be something like this. Okay, with the quality planning, this is a cumulative profile of the total effort. So one stacked on top of another. So quality planning, you probably start doing a lot of planning. Of course, at the beginning you do more planning. You don't do planning at the end. Planning at the end is useless planning. It's maybe good planning for the next one, but it's not for this one. Okay, so you spend most of your planning effort really close to the beginning part. Okay, and winding down here. With the quality assurance, you'll probably start really slowly. You do maybe a little bit of review of your requirement and other things. Okay, and then when you are doing the coding, inspection, and the testing, that's where you do most of your quality assurance in terms of amount of effort and the time consumed. Okay, and the quality analysis and the improvement and the control, that's the overall feedback mechanism. That probably follows the quality assurance activities, because only after you have the quality assurance activities, you have enough data, you will analyze it, and then you will provide some feedback. Okay. In the very beginning, you probably don't care about analysis because you don't have any data yet. Okay. But you may prepare a little bit, but you probably won't do much. Okay. So that's the overall profile, expected profile of those kind of things, how things will be working. Okay. And one of the questions in the end of the chapter is ask you to discuss the different other processes. What's the distribution and the things. Yeah, the thing is that you can think in the general logical ways, like for example, if you are doing the iterative development, try to look at some of the things you do the whole cycle and then you move on to the next one, or maybe you're doing the spiral guided by your risk areas. Then essentially you have this thing, the this distribution all repeated all over the places. So in that case, you will probably end up with a kind of more even distribution of the overall quality assurance activities over the long run, okay? Which actually is one of the advantages of those kind of strategies. Okay, so you are not just doing one thing at a time. You are kind of going over the things and going into in an iterative fashion. Okay, so that's why nowadays actually iterative, spiral, extreme programming, agile method are gaining more ground, and traditional waterfall is still used for large software systems, but it's probably not as kind of strictly followed for smaller projects and for the more volatile kind of market. Okay, so that's a kind of a quick. We did cover a little bit of about the chapter 5 before, and so that's a quick coverage about chapter 4 and chapter 5. Okay, so let's take a little bit of late break, and so we'll come back after 10 minutes, and I will go through the testing overview and go into a little bit of the testing techniques. Okay. Actually, I changed the office hour. I posted that. Yeah, sorry about that. Yeah. Because I had something in the afternoon, so I changed it from 1:30 to 4:30. You check out class webpage.
I just.
Oh, I'm sorry. Probably focus more on this part, so the strategy. Yeah, if you want to use those things, give a very brief justification why do you think that's appropriate. Okay, and so spend
Because I'm recording.
In general, so just expand more on technical part. Yeah. Solution strategy.
What about
Talk about from the perspective and the technique and so on. Because this is the perspective you want to see. This is this is the level of detail you have to go here. So this is the appropriate testing techniques. So basically, looking at the perspective since you want to justify share techniques.
No, I can't down. That was it. Possibly I do like the network just on the computer work and back that. I think he'll ask for like specific example. Yes, what? I mean, he expects. How long is this next chapter? This one is 1 hour.
That is whatever was in the previous exam is there.
He bought the book and
The audio is
you should have sent the document. Book and audio. Yes, sir.
next week we have
By next week I'll do it. Can we have 6 chapters?
yeah, that's true.
No, I can.
I would have taken it but I don't have it.
I can do
Okay, let's go back to our class. Okay. As I mentioned before, when we did the chapter 3, we did kind of go into a little bit more details about the different quality assurance techniques. So much more detail than what was in chapter 3. Okay, so in a sense, our chapter 6 and 7 were covered to a little bit degree, particularly chapter 6 is all overview about testing, and so it's a kind of a little bit more than what in the chapter 3 did, and actually when we did chapter 3 we did much more than that. So we did look at some of the testing related questions and the testing technique questions and things like that. Okay. So what we are going to do next is that actually I'm going to kind of quickly review some of the things that we talked about already, and then the things that we haven't talked about already, I will go into a little bit more details. Okay, so I expect the chapter 6 and 7 can be finished fairly quickly as well, because we kind of spend time on the related material and topics already in connection with the survey about different quality assurance techniques. Okay, so let's move on to chapter 6 first. Okay, so chapter 6, as you can see, is basically an overview about testing. So we did kind of a little bit higher level overview, but we can dive into a little bit more details here. So what we are going to do here is looking at the concept and the process and the related questions and then major techniques. Okay, we kind of looked at each of them at some level already, probably not as much as what is in chapter 6. So, but after we discuss this, I expect that you will be able to read the book and so get more of the detailed discussion about the things. Okay. So if you look at this, testing is part of the overall QA, and as we mentioned about, it's the center part, okay, and also the central part, one of the central parts, okay, of QA, where if you have some defect already injected into the system, we try to go through testing, get to the defect. Okay, so we observe the failures, try to reproduce it, try to locate what's the fault that caused the failure, and then remove the fault, retest, and make sure it's fixed. Okay, so that's basically what we are doing with the testing. Okay, so that kind of how it fits into there. Okay, so it's a part of the QA. Its activities will be focused on their testing phase, but it may spill over to other things, particularly when you think of non-traditional waterfall processes. Okay, test-driven development, agile development process, and looking at iterative spiral, incremental development, and all those kind of things. So you will do testing much earlier, okay, and almost test consistently. Okay, and so our key questions will be look at why are we doing the testing, how do we do the testing, okay, and from whose perspective are we doing the testing, and when are we going to be done with testing. So those are some of the key questions, okay. Actually, we didn't talk too much about the why question as much. We talked about testing will reveal the defects, okay, but then another part of it is really, it's also original purpose of testing. When you consider testing for other things, it's less of a defect fixing. It's more of acceptance. Okay, so when you think of the testing of a traditional product, okay, think of you test drive a car. You are not trying to find defect for people to fix. That's not your primary purpose. The purpose is to demonstrate that this car is really perfect or as perfect fit for you as possible. Okay, so you like this and this and this, whether this car performs, handles like this, this, and this, fits your expectation, your requirements as much as possible. Okay, so essentially, if you think of a test drive a car, you are really more looking at a demonstration of quality, okay, rather than finding problem and fixing problem. You don't care if it's something you don't like. You don't care whether it's fixed or not. Okay, you move on to the next car and the next model and then make a model and then you test it. Okay, when you test some other product, it's a similar things. Okay, you test some daily use product and you say, oh, okay, I'm going to buy this, and then this one is not working for me, and then if the store is nice enough, they will take it back, and then you can buy something else. Okay, and so you are not really looking at the defect fixing as much. So the original purpose is more of a kind of a quality demonstration. Okay, but in software, mainly there are several reasons that we focus on defect fixing. Okay? One thing for that is that we do have the flexibility, because software is quote-unquote easy to fix. You can disagree with that, but compared to other things, it's easier to fix than other things. Okay? Once other things is committed, okay, that the physical form of energy has been applied to things, and then it's much harder to fix than software. Okay, so if you have a small problem with the software, it's easier to fix. Maybe it's not as easy as people think. Okay, but it's comparatively easier than other things to fix. Okay, so because of this, we get the kind of the advantage. And some people say we got the curse of this flexibility, because the software is so flexible, we can fix it so easily, and so we get to be asked constantly fix things. Okay, so that's one of the things that we have that opportunity to do this. Okay, but the thing is also another thing is that if you think of once you have produced your software, and it will be distributed, okay, through CDs, through downloads, through various other means. Those processes are generally more reliable, more robust than the software development process itself. Okay, you can say, okay, I distributed this on the CD. It's not so common, not so common to have some kind of copying error to a CD. Okay, your manufacturing, it just duplicated on the CD. It's probably, if you duplicate 1,000 CDs, and then maybe 999 are okay. Okay, maybe one out of 1,000 is not okay, and I threw out that bad one, and then once you check, it's okay. It's probably going to be okay because of the digital copying, the nature of the digital copying. Okay, and so and if you think of the download, they probably didn't successfully download, but then you can try again, and then you can download the whole thing, check it's okay, and then it's going to be an identical copy of your original. Okay, so we do have that kind of a different characteristics, so that will allow us to focus on really defect fixing. So that now really defect fixing become more important for testing than quality demonstration. But still, you can still use it for quality demonstration. Okay, for example, we use this graph here. This graph can be used for part of the problem fixing. You observe the problems that will be fixed. Okay, but the thing, the overall trend, you are really looking at the demonstration of quality. Okay, so you but how do you get this data? It's probably through testing, and most likely there's a usage-based statistical testing. Okay, so you still have that dual purpose of demonstrating quality and fixing problems. Okay, and so that's the why question. The how question is that generally can be answered by this one. It's in the rudimentary level, is you run the software and see what happens. If something goes wrong, try to fix it. Okay. So if you look at the overall process, it's like this. Okay. So you have some execution. You run the software, see what's wrong. If nothing wrong, go on to the next one. Go on to the next one. Go on to the next one until you are done. Okay. So that's kind of a lot of hand waving there. But you say, okay, start executing. How do you start executing? Which one to start? So in terms of the specific human intelligence involved activities, you need to do a lot more in terms of planning. Okay. So before you actually start executing, running something, you need to plan. Okay. You need to set what goal you try to achieve. What kind of test are you going to do? When you do what kind of test, so you will be doing this test and you will involve those many test cases. To do those, getting those test cases, because for any of the large software systems people count on, you have to do very systematic testing. If you want to do systematic testing, you need some model. To get those models, you need to collect some information, collect some data. Okay, so the end result is that you need some test cases that you can run. But to get to this test cases, you need some model be constructed if you want to perform formalized systematic testing. And to construct those models, you need to gather all kinds of information. Okay, and so then you also need to consider what kind of a test procedure you want to use. Okay, what kind of things you will be doing first, what kind of things you will be doing next, and what's the overall procedure. Okay, so this block is big. I'm sorry, I need to switch over. Okay, so this block is big for a reason, because we do most of our activities, intelligent activities, in the planning and the preparation phase. Okay, and then we can do the execution. And while we are doing the execution, we'll keep track of the things, and we will keep track of the data and analyze the defect and fix the defect and look at whether our overall testing goal has been achieved or not. And then if it has been achieved, we can stop. If not, then we can go back and maybe make some adjustment and go on with some more testing. Okay. So if you look at this picture and the picture we looked at before, SQE, it kind of looks similar, very similar. You have some execution activities in the middle, and you have some planning, preparation in the beginning, some monitoring, adjustment mechanism, and some kind of criteria to end it. Okay, so that's you can think of this as a kind of specialization or customization of the SQE process applied to the testing process. Okay, and then in doing this, then you have to answer all kinds of questions about okay, what are the things you are testing, and how do you test it, and what's the goal, and to reach that goal, then you will kind of decide how to reach that goal. That may involve using different testing strategies from different perspectives and using different stopping criteria. Okay, so we can look at a number of those things. We have the activities, the planning, execution, analysis, follow-up. Okay, and you link them together. That's the testing process. Okay, and in the planning and the preparation, you basically have to set the overall goals and the strategy. Okay, and then you prepare a test case. In terms of preparing a test case and test procedure, you need to do a lot of other things that in terms of if you want to do a good job. Systematic, formalized testing. So you need models, you need to collect information and do all those things. Okay, so we'll talk a little bit more about that later on. And then execution, you need to run the thing. Okay, and we'll actually in chapter 7, we go into much more detail, so I can skip this now. And analysis follow-up, similarly, you need to analyze, keep track of the things and the follow-up. Okay, so that's the overall kind of way of doing that. Okay, and then how exactly to test those things? Okay, you say, okay, I will have test cases. Okay, how do you get your test cases, and how do you run your test cases? Okay, so we will be looking at some of the basic questions and some testing technique questions and activity and management related questions. Okay, so lots of questions that we can ask. Okay, so some of the basic questions we want to talk a little bit here that we haven't talked about too much before. We actually talked more about the techniques and perspective and things, but say what artifacts that we haven't talked too much about here. We want to talk a little bit, and what to test from which view, and the type of the problems found, when to stop testing. Those questions we kind of looked at, okay, and we will review them again. Okay, so there also be testing technique related to the questions. Okay, and techniques and models are closely related. We'll come back to that. Okay, and there are also some activity and the management related questions we will talk about in a little bit related to the chapter 7 slides. Okay, and so actually let me skip forward for a little bit. We talk about the usage-based, okay, different types of testing. Okay, so in terms of the major testing activities, okay, and planning, execution, analysis, follow-up, okay, talk about the basic questions, okay. So when you look at what are the different artifacts are you're testing, okay, that may divide your testing into different test subphases, okay. So for example, that you can start from your very beginning, looking at the kind of what kind of artifact. Are you testing a small part, a big part? Okay. So that is actually related to some of the slides we looked at before over here. And actually, I should bring that up again. Chapter 4, we have the V model. Yeah, okay. Chapter 4, we have the V model here. Okay. If you look at this V model here, okay, and actually, when you are looking at this, you are looking at the different artifacts that you are testing. Okay. If you are testing the individual code, you are doing unit testing, individual unit at a time. And if you're testing your component against a low-level design, you are doing the component testing. Okay. And so you can look at the different artifacts that tested and look at the integration of the different components into the system as you are doing integration testing, okay, and the system testing and the operational use. So those different testing, really, those different testing subphases essentially address the question about what are the particular artifacts that you are testing at what level. Okay, and of course you can also look at this artifact from another perspective, is that what kind of product this is. Okay, what kind of language, implementation language it is. Okay, so you can divide your testing that way, but that's not really fundamental to testing itself. Okay, so you say, okay, I'm testing a commercial product, I'm testing a web-based product, I'm testing a telecommunication product, I'm testing an aerospace kind of related embedded software product. Well, that had some peculiarities to that particular testing, but typically you can still use various different testing techniques and different strategies. That's kind of common that can be used across all those different products. Okay. And then you can say, oh, I'm doing Java testing, I'm doing C testing, I'm doing C++ testing, I'm doing Fortran testing. Well, it doesn't matter. Whatever testing you use, the implementation language you use, you probably have some of the common techniques that can be used no matter which language you use. You can look at the control flow. Doesn't matter, it's Java or C or C++ or Fortran or even COBOL. Okay, and You can do some data flow, data dependency analysis. You can look at the partitions, the input boundaries, parameter boundaries, and all those things. Doesn't matter which language you are using, right? So when we look at a particular testing, more in-depth testing questions, typically we can kind of go beyond some of the basic artifact distinction and go into the core about the techniques and from whose perspective, what kind of technique, what kind of model, what kind of stopping criteria. That will be more kind of fundamental to testing than those other things that we mentioned about, so for example, the artifacts, okay? And so now I can go back to this one, okay? And then what to test is the most important thing is about what's the perspective, okay? From whose perspective, okay? And then from whose perspective is probably going to be related to what kind of a problem you will be finding with that kind of testing, okay? And when do you stop testing, okay? And so when is it enough? So we can look at those important questions that will give us a distinction about some of those important techniques. So we talked about the various techniques, okay? So when you look at the techniques questions, typically you look at are you using some systematic technique and models? Okay. If you want to do systematic testing, typically you have to have some model, okay, and to keep track of the things, okay. And so there are lots of model questions, okay. And when you look at the techniques, they are typically cutting through different application domains, different implementation languages. Okay, we mentioned about that. Okay, and oftentimes that similar to our discussion about QA activities, we say we are typically not just running one QA activity to the exclusion of all other QA activities. With testing, typically we are having a combination of different testing techniques implemented for a reasonable size product. Okay, so trivial products like trivial programs like maybe a few lines, maybe a page or two. Those things we probably don't need to consider this many of the questions. But for any of the realistic, useful programs and the software products, we probably need to do some systematic, formalized testing supported by some models. Okay, so when we look at the models and look at the derived models, there you can look at the underlying structure and how the model is constructed, how it's used, and from what perspective. Okay, so underlying structure, there are many types, but there are typically two fundamental big classes of models. One is based on some kind of list and partition. Okay, so you're looking at some kind of division, divide something set and list or partition. Okay, so but that is a kind of like a flat structure. Okay, without a repetition typically. Okay, and then another type of models is based on so-called finite state machines. Okay, so we mentioned about some of those things in the last class. Okay, and actually I have seen people start to discuss with me about their project, and some people said I'll be looking at some kind of partition testing with what kind of things, some boundary testing, some kind of control flow testing, finite state machine testing, or whatever kind of testing. Okay, and so those models, you have some underlying structure, and they will be constructed based on some information you collect, and they will be used to generate test cases. Okay, and oftentimes you can extend the model to do certain other things. For example, you have the finite state machines, then you can not only support the coverage about those different states that you want to visit, but also the overall execution path. Okay, so that's a natural extension of the finite state machine. So you are not just looking at the individual states and the individual links or transitions from one state to another, but you're looking at the overall execution path. So that's a natural extension to that. And so we will see various natural extensions to different basic model structure. Okay, so I think in the last class we also looked at some examples here. Okay, for example, we look at over here, and then we say, okay, we can do the partitions, and then based on the partitions, we can also do the boundary testing because we observed there are lots of likely problems around the boundaries. So we do the boundary testing, okay, and then we can do the representative testing. If this one is used much more often, we test it more often, okay. So there are many of the model extensions that can be used to support some individual major testing techniques. And we will be discussing many of the techniques, okay. Activities, as I said, I will talk about a little bit later. So about the different types of testing, we mentioned about functional versus structural testing, okay, or black box view versus a white box view, okay. Essentially, the key distinction is that on what perspective you are looking at external functions, or you are looking at the internal structure. Okay, if you are looking at the external functions, you are adopting a kind of a customer user's view. I care, or maybe I only care also, or at least I care more about what this thing is doing for me. Okay, so I don't care as much as what is the internal implementation technology, internal implementation details. I may care a little bit because I may have some knowledge. I say, oh, if you use a very old language and for this new platform, I'm not so comfortable. Well, that may be the case, but in most of the cases, they don't care. Okay, so if you have a, say, for example, you use some apps on your mobile device, you don't care what is implemented. They can be implemented on, you use assembly code, you don't care. You're using some JavaScript or you're using some other things, whatever, okay? As long as it's doing the things and doing things correctly and fast, I'm fine. Doing the right things and doing it correctly and fast, I'm happy with it, okay? So that's the function testing. So you basically look at their test their external functions, and those external functions as described by the external specifications or the user requirements, okay? And so it's a black box in nature. You care about what goes in, what comes out, but you don't care as much as what's inside, okay? So this is one thing is that sometimes people say, oh, I have the code, so can I still do black box testing? Sure, you have the code. You can ignore the code. You just look at the function, okay? And sometimes you can use your knowledge about code to help you with the functional testing, but as long as you focus on the external functions, you are doing black box. You can see it, it doesn't matter. That doesn't make it non-black box testing. You can pretend that you are not seeing it, basically, okay? And you are testing the external functions, so you are doing the black box. So it's not something you have access to or not. It's something, are you choosing to focus on the external functions or not? Okay, if you're focusing on the external functions, you're doing black box. Okay. Well, but if you don't have the access to the code, to the product internals, then you cannot do white box or structural testing. Okay. For most of users, actually, if we want to do testing, all we can do is black box, okay, perspective, not the white box. But if you are the developer or if the product is open source, somehow if you have the access to the product, its components, and its source code, you may be doing white box testing. Okay, I said you may be doing white box testing because you can still ignore it and doing black box testing. Okay, so if you focus on, okay, I'm trying to make sure that this part is tested, this part is tested, this line is tested, this if statement is tested, and both the true and false conditions of this if statement is tested. So when you are looking at that level, at that internal information, you are doing the white box testing. Should be called clear box, but we got stuck with the white box name here. Okay. And so the main thing is really black box versus white box is really looking at what you are trying to test. Okay, and I mentioned about sometimes people say, oh, I'm doing some gray box, some black box, some white box. I prefer not to use the gray box because they can be confusing to people. So when you are saying you're doing gray box, then maybe you are doing some black box or some white box. I would prefer you say you're doing what black box or what white box instead of you doing I'm doing gray box. Okay. So for example, that if you are looking at a system made of many different components, okay. So when you look at this, you are doing the, for example, in doing this, okay, you are looking at the testing system maybe from different perspectives. I say, okay, how those different components are connected to support my system function. When you look at that you are doing the white box testing because you look at how they are connected together, how they are working together to support the overall function. Okay. But then you say, okay, from each of the component perspective, you're not looking inside. You're making sure that when you're doing that testing, when you try to connect those components together to look at how it works for the whole system, you're not looking inside the component. Okay, you're looking inside the system, but you're not looking inside the component. Okay, so at that level, at the component level, you're doing a black box because you're only looking at this external function and this external function and the external function for another component and how they match together. Okay, so from the component level, you are doing the black box. From the system level, you are doing white box because you see inside the system looking at the component. So whenever people tell you that they are doing gray box testing, try not to just stop over there. Try to say, if you are doing gray box, so which part are you doing? You must be a mixture of black and white. Okay, so which one you're doing in black, which one you're doing in white. Okay, that will be a more interesting question to ask. Okay, so that's why for your project, I don't want to see any gray box testing. I want to see black box testing at what specific level, white box testing at what specific level, but not the general gray box testing. Yes?
When people say they're doing unit testing, what does that actually mean?
Oh, when people say unit testing, basically people say a very small unit. Okay, typically for small software function, a small module or something like that, a small component. And when they do the unit testing, it's that they make sure the internals of that unit is working.
Okay.
Okay, so that's typically, so when people do the unit testing, typically it's a white box looking at the instruction level, data level, or some of the kind of dependency within the unit. Okay. Yes?
So are you saying you should do either black box and white box?
You will be doing a combination, but for each individual ones, you tell me exactly you are doing black box or white box. Okay. So, for example, in that case, we talked about the look at the connection of the components that make up the system. You testing the connection. That is the white box testing at the system level. Okay. And then to do that connection, you have to make sure each component is working. Right? And when you make sure each component is working, and without looking inside, you are doing black box component testing. So in that case, you are doing black box component testing and white box system integration testing. Okay. So that's a combination of black box with white box, but not. I don't want to say, you say just generally say I'm doing gray box. Yeah, black box testing of the component and the white box testing of the system integration.
Can it be the other way around?
What's that? I didn't get it.
Can it be the other way around?
In this case, probably not, because the higher level, the lower level thing. Okay.
So you want a more higher level?
Yeah. And usually, when people say gray, it's usually lower level black and higher level white, because you hide the details and then you have some details at the higher level. Okay. So as I can't think of an example you can do the other way around. Probably not. Okay. Yeah. Okay. You need to look at this things, particularly looking at the levels and the representation. And so, for example, one of the things I mentioned about for your project, you say you have a large product you are working on at work. Okay. Of course, you cannot just test the whole thing comprehensively by yourself. But you want to do black box, you can focus on the very high-level functions. That's fine. Okay. And then when you move down to individual module or individual component, you say, okay, now I can do some white box testing. That's good too. Okay. And so white box testing is that you have the program component structure knowledge, and you not only you have the knowledge, you are using that knowledge. You may have that knowledge without using it, you are not doing white box. Okay. So you have the code. I'm just focusing on the external functions. Then you are still doing black box. Yes.
Is white box testing practically like editing the code and seeing the new output?
Well, that's one type, but you can do all kinds of things with it too. So, for example, that you're adding the code and the thing the output is what you're doing there is that you look at the code level, line by line, and instruction by instruction. Okay, and sometimes you are not at that level. You may be, as for example, we look at how different components fit together in the system. Then we will look at how different components fit together in the system, how they work together. That is the white box from system level. You are not changing the individual code there. Okay. And the white box testing, typically you can do it in the small and the early. Okay. But for the large system, then you can do it later, but at the higher level, but not at the very low level. Okay. But the black box testing, you can do it in almost any place, especially if you think of it. The modern programming practice, the so-called object-oriented programming, the information handling, encapsulation, all those things, is really moving the system down to the unit. Okay. So instead of a system has some function that you define the small unit or your object with some functions. Okay. The predefined object and predefined operations on the project. Okay. So in that case, that you are trying to look at what's the external function. You focus more on the external function of the smaller unit instead of the whole system. Okay. So that makes it more likely to be reusable because you can replace it with something else if as long as they are having the same kind of function and the same kind of interface typically. Okay. And so black box testing is you focus on the input-output behavior, okay, and which can be specified by some kind of list, like a functional list. This one provides this and this function, or they can be specified by a finite state machine, okay. And the finite state machine said that under this kind of situation, your system should perform like this. Okay. Oftentimes that you were giving some of the system specification in that kind of form. Like for example, in the telecommunications industry, they specify the different telecommunication protocols oftentimes use finite state machines. Okay. So it's under this kind of situation, this should be our system behavior. Okay. Instead of a list of the things. Okay. So you can use that to do your testing. Typically late in the system, but with the object technology and the encapsulation and the reuse and the things, you can move that to the earlier part as well if you have encapsulated small components. Okay. And so those are some of the basic questions. And then another big question. So from the perspective, we say, okay, black box versus white box. Then another big question is that when do you stop testing? Okay. So there are several different ways of when do you stop testing. Okay, if you look at the process view here, essentially, if we are doing testing, we are trying to achieve some goal. If we are trying to achieve some goal, we can stop testing when we reach that goal. So that's goal driven. Okay, and so in that case, that when to stop testing is basically how do you specify your goal and how do you measure your progress against that goal. And that is basically answers how to when to stop testing. Okay, so if you measure the quality directly, and then you say, okay, I will reach this reliability level, then I can stop testing. Then what is the reliability? We defined before, reliability is the probability of failure-free operations for some specific time period or some specific given set of input. Okay, and so how likely you are going to fail given this much time or given this much of the repeated operation with some input. Okay, and then if that's the case, then I say if I reach my reliability goal, I can stop. See, reliability is defined with respect to your usage. Under this kind of this much time of usage, this kind of usage scenario, and if you want to care about what customer sees, and you want to care about you care about your business survival, you will care about what the customer sees as the reliability, how often they experience problem. So in a sense, is that you need to make sure any problem that's likely to be experienced by the customer need to be fixed before product release. Okay, how do you do that? Then you essentially have to know how the customer is going to use your system, and then you can simulate the customer usage, so you know how reliable this product will be. Okay, when you do that, you are doing the usage-based statistical testing to for reliability assurance. Okay, so that's what we call the UBST, okay, usage-based statistical testing. Okay, typically you need some usage model for your customer. Okay, so that the usage model in the testing and the software engineering literature is called the operational profile. Okay, so you need an operational profile for your customer usage. Okay, so that's your usage. Basically, it's a usage model or your system operation. Your system operation will satisfy this profile. Okay, so that's your usage model. Okay. But oftentimes, especially for small units, you probably don't have the operational profile. Okay, so I don't know how reliable this is going to be and how the customer is going to use it. But I want to make sure it's defect-free. Well, how do you make sure it's defect-free? I say, I can cover this kind of input, I can cover this kind of input, I can cover this kind of the dependencies, I can cover this one things. So you make a surrogate, okay, a substitute for your reliability and usage. You say, if I do these things correctly, most likely I'm okay. Okay. So in that case, we do the so-called coverage-based testing. We define some coverage if we don't have a direct definition of usage and reliability. We can define some coverage. And oftentimes we can do some coverage here. So for example, that we have this one over here. I can cover coverage that my overall input space can be divided into A, B, C, D, E, and F. So I make sure that input from each of those subset or subdomain will be at least tested once. Okay, so that's some kind of coverage criteria. So I may not exhaustively cover all the input combinations, but some typical type of input combinations, each type I will have a representative sample for it. Okay, so that's coverage-based testing. Of course, your coverage can be defined by various different models or different criteria. Okay, so for example, with this model, you can also look at the coverage for the boundaries. Okay, and the coverage for various other things you can define. Okay, so if you have a finance state machine, let me see if I have a finance machine somewhere here. No, I don't have it. If you have a finite state machine, for example, you have a finite state machine like this. This from A, you can move to B. From B, you can move to C. And then C, you can go back to B, and then go back to A, and then go to D. For example, that's your finite state machine. Okay. Then in this case, I say this is the initial state, and this is the final state. Okay. So this is the absorbing state. Once I get in here, I won't, will never get out. Okay. But I start from here, and then so maybe I will get going through this loops, and then eventually I will get out. Okay. So in this case, I can say, okay, I can do some coverage too. For example, one type of coverage is I'll try to cover this, cover this, cover this, cover this. Then I'm fine. Okay. As long as I cover those things, I'm fine. I'm cover all the states. Okay. But when I cover all the states, I may not cover all the transitions. So for example, I can go from here to here, that I cover the A, cover the B, go to here, cover the C, go here, cover D. I never test this one, never test this one. Okay, so just doing the node coverage may not be enough. I say, okay, I need to do the link coverage. Okay, I cover this link, I need to add this, I cover all the links. Okay, but then I say, okay, what about this is a loop? Can I always get out of the loop? And so if I go into the loop, can I get out in n times, or what? Is this an infinite loop? Once I get in, I can never get out, or what? So I need to do some kind of a path coverage. So you can do all kinds of coverage defined on some basic model. Okay, and so if you have the basic finite state machine, you can do the state coverage, link coverage, and then you can extend that finite state machine to look at some path coverage. Okay, path coverage will include the loops and the loop testing, and then you can look at some of the dependencies among the different states. They have dependencies among the variables in the different states, and then maybe you can do some dependency coverage. Okay, so that's a kind of a coverage-based testing. Okay, so most of our formal testing techniques are either usage-based or coverage-based testing. Okay, and then you have some of the informal testing techniques that maybe say, when do I stop? When I stop when I run out of money. When do I stop? When I stop when my manager tells me to stop. Okay, well, in a sense, that is what happens a lot of times. Okay, but that should not be an excuse for us to do a lousy job. Okay, and so if we stop when we run out of time, then we should plan ahead. We have this much time. What's the best we can do? Okay, best we can do is probably improve the reliability to the maximum extent. So in that case, even though we know we have to stop at this point, we will be using the usage-based testing if it's available. We have to stop within 1 month, and I want to make sure every major component is tested at least once. Okay, so I will try to test all the important high-level components, and then I can move down to lower-level components. So that's still some resource-based decision, but I can try to maximize my reliability, maximize my coverage, or maximize something within that constraint. Okay, so we shouldn't just give the excuse that we have to stop and we are not doing a good job. We have to stop, but we can still do a better job if we are careful in terms of planning, in terms of optimizing and making the wise decisions and optimizing our strategy. Okay, and so basically what we try to do is that we try to do this quality-based criteria, and even if we have to stop for some external constraints, we try to optimize based on some of the criteria that will help us maximize the quality from the external perspective if possible, or at least from some kind of coverage perspective. Okay. So usage-based testing, we talked about there will be operational profiles, usage models, and typically they are very much useful for the final stage of testing. when we have the whole product and we can simulate the customer usage. Okay, and then coverage-based testing is oftentimes in the earlier part of the development. We don't have the complete system usage information. It's hard to simulate the system usage from the customer perspective. Then we can try to find some viable surrogate, and so typically it's some systematic coverage of this and that and all kinds of things. Okay, so it can be black box, can be white box. Okay, so when you do the coverage, you want to cover all the major functions. For example, external functions. You can cover all the internal components. So if you are covering internal components, you are doing white box coverage. If you're covering external functions or your external finance state machine modeled behavior, you are doing the black box coverage, right? And so when you do coverage, you can do black box or white box. What about when you do usage-based testing? Are you doing black box or are you doing white box? Yeah. When you do usage-based testing, it's mostly the black box. Okay, you can map it to some white box components, but your focus is on the black box usage view. Okay, the user view not only what they are using, but how to profile them, how quantify them, and so that you can test them accordingly. Okay, and so that's the black box and the white box. Steps, I guess we talked about steps, so we can finish here. And so that's the end of this testing related questions. Okay, so let's take, again, that take us to a little bit late stop. And we didn't spend a longer time here with this segment, we just stopped a little bit late. So let's take a 10 minutes break and then we'll come back and I'll try to wrap up the other things. Okay.
Oh, that's
Okay.
Okay, what is data? In copy and paste it for the year 2012, and we are doing some analysis. This is asking for us.
You taking this class too? You know what he sounds like. He's a little aggressive, smart. Did you hear it? Do you see how sarcastic he was? I heard mine now. I mean,
Two for you, two for you. Four. Yeah, I think that's good. I got all the questions. Alright, you go down to school. Share this one more. That's one for her.
or you need to help the teacher, you don't understand the concept. No, but I'm serious, like, you have like.
Yeah, I hope to continue a long-term relationship.
I know. That's why. Oh no. Yeah. Oh yeah, there's 2 books. Yeah.
Oh, he has to say you.
Not this one. That's this.
Come on, this one. Well, I think I'm gonna, hopefully he'll agree with me. trial version of one of the hiring ones and see what if they're better or easier to write a letter. Hopefully, get that within a month.
I have. What is the class?
No, you gotta make sure everything is stuff. I mean, I figured out what, I think I figured out what that is. You gotta make sure you do it. I have, I figured out how to download them.
I'm just, that's what
Well, that is true, that is true. Figured out how to try to do my defect mapping or vulnerability like that. Using concepts I learned from
Yeah, I have the video. Yeah. Wanna see it? I have the video.
oh my goodness, you wanna see it. It's like you got pictures. Like you see here, this is my man right here.
Yeah, no problem. Even during the class when lecturing.
You should be, but I've not done this kind of stuff. I've done written format.
I've done you I only won once. You've done so many times.
And I've done many weekend format.
So what's going on? What you're fighting for?
I think I have one kind of
Yeah.
So his basic, so pretty much his goal is how to do it. And we want you to do it.
but that's okay when you're that 400 is nothing.
You can buy our semester books.
Like, I'm doing this on my pages. I'm doing this to back.
But that's too bad. Because they have all kinds of different rules. I didn't know. They gave me, but I didn't take it.
Just like, if he has a
So he's just gonna go, right? Just write a little bit about it. Yeah, do it. You're talking about the project, right? I guess it's gonna cover everything.
That is silly because I do have like all that. They won't allow distance limits to one hour. I want to get 2 days extra.
So, let's see, the last time we did that was like chapter 6, 11.
I don't have the code.
I have time. I'm just seeing where the midterm is. It's like the chapter 9.
Oh, yeah.
And this says here, I don't know, 14 to 16. I don't know.
I think that was
Something, I
part
got something I know. Well, I know this right here is hard right here. I just have to remember what he's talking about.
it's the same unit. I the button. Take it this way.
Cities 9,000.
There's so many definitions. Then what are the kind of goals?
Yeah, but
Yeah. Focus on only different environment should understand everything.
see, I don't know.
I hope it's not too long. Yeah. Well, they have the gap on it, so not inductive, yeah. But this is mentioned that. Oh, yeah. So this is the next level. This is but it doesn't have. Oh, wow.
Because I
I feel not as stressful as yeah. Some people can understand the process
Okay, let's go back to our class and try to wrap up other kind of testing related activities and management and automation kind of questions before we move on to their individual testing techniques. Okay. So let me switch over. Okay. So this is the actually, as I mentioned, that chapter 4, 5, and 6, we kind of talked about already to some degree before, and this one also some of the things we covered to some degree, so we can go over fairly quickly. So in this topic, we basically looking at the three things. There are major activities we looked at already, and look at a little bit more detail what are the sub-activities involved, and looking at the management, general management kind of strategies. We probably don't need to spend too much time there. Testing automation, we really want to set some kind of expectations about the automation, because one of the common misunderstanding and wrong expectation area is with the test automation. Okay, so we want to make sure that we have the kind of right kind of expectations for test automation. Okay, so as we mentioned about there are three major parts of the activities: the planning and the preparation is the one part, execution is another part, and some kind of analysis and follow-up and wrap around the mechanism is the third part. Okay, so we'll be looking at this planning preparation first. So when we divided this, actually I should have checked this slide earlier. We had their picture here and generic process. Where's my process picture? Okay, I'll keep this one here. So you can see in terms of planning and the preparation, we're trying to do some high-level planning and low-level preparation. So that's where we draw the distinction between planning and preparation. Typically, we are looking at the high-level planning of the overall goal and the strategy. Okay? And the preparation then will be preparing basically two things: preparing the test case and preparing the test procedure. In order to prepare the test case, we need to gather information, we need to construct a model, and then derive the test case based on the model. Okay, so those are the kind of things that we try to plan and prepare. Okay, so here we No, not this one. Let me see. This is the one. Okay. So that's what we need to do. So in terms of planning, there is a goal setting. That is kind of similar to the goal setting when we talked about the overall quality engineering process, but it's now specific to the testing activities, the testing strategies. Okay, but you can apply the same kind of rules. Generally, if possible, try to adopt the customer perspective and try to quantify quality from the customer perspective and manage your system progress towards that objective. Okay, and if not, then you try to find some surrogate and try to say if this is a good surrogate for this, and then you can do this. So actually, when you are preparing your project proposal, think of this. Okay, your goal is doing what? Okay, and then based on your goal, you maybe find the particular testing technique and strategy that you want to do. Okay, and for example, one of your goals is probably looking at I'm looking at this from the customer's perspective. I want to make sure it's reliable. It's not going to cause a lot of problems. Then, if you want to do some usage testing, some black box testing, then you can go from there and then use that to justify your selection of this particular testing strategy. And then you say, oh, then for this one, it's a really dynamic system, and then it has a lot of kind of expected behavior under different situations, so I will use finite state machines instead of using a checklist or a basic partition. So you can use both the objective and the kind of characteristics of the function or the characteristics of your product to justify your selecting this particular testing strategy that includes this and this testing technique. Okay, and sometimes you say, oh, I cannot get the customer perspective, and it will be impossible for me to gather the customer information, so I'll do the black box, but I will not quantify the usage. That's fine. Okay, so then whatever black box testing technique that you use the coverage, that's fine. Okay, and you say, oh, I do have this access to the code, and I want to focus on some of the critical part, make sure that it's tested as thoroughly as possible. Then that might be a justification for you to zoom in on a small part to do white box testing. Okay, because that's the critical part based on whatever analysis you performed with customer information, with the product knowledge or whatever. Okay, and so you can use that to justify your strategy by looking at your goal and looking at the overall environment and the knowledge about the product. Okay, and one other thing that you might consider during this proposal stage of your project is that, of course, one of the goal that's not necessarily a goal for testing. A goal for you maybe is to maximize your learning from this class through your project. So one way to maximize your learning and maximize your exposure to different things is that you can use that to justify using techniques from different perspectives, focus on different levels or whatever kind of diversity kind of from a learning experience point of view. Probably doesn't make too much sense in the company if you are doing this alone and you are selecting two extreme things and do it, but it might be a good learning experience. So that can be used to justify this as well. So your testing goal may or may not reflect the actual working environment, but for this class, for this project, you may have some testing goal that is a kind of you can use to justify selection of your strategy. Okay? And so your overall strategy will look at what you are going to be testing and what technique you are going to be using, and typically techniques, not just one technique. Okay, and so what about how do you track your progress towards that goal? Okay, and and those activities you will be used to monitor and to analyze, to follow up mechanism that you to use to control the overall process. Okay, so plan the whole thing out. Okay, so the high level, it's kind of like in our planning for the overall SQE process, some goal-related, strategy-related, measurement-related, control and analysis and feedback mechanism-related things. Okay, so that's a high-level planning, and then for the preparation, as we said, there are basically two things. One is the test case, one is the test procedure. And then it can be broken down into various smaller parts. Test procedure is really something you need to pay some attention to as well as the test cases. Because when people say preparation, typically people will think, oh, I will have this test cases. But you also need to prepare the testing procedure. Okay, what to do in what kind of sequence. Okay, and the procedure sometimes that you will need some kind of, let's talk about procedure first. Test case, okay, that's kind of simpler, so we can talk about procedure first. That basically some kind of sequencing. Okay, so when you look at the sequencing, then you look at okay, if you have a lot of test cases, how do you sequence them? Okay, one of the common effective way of sequencing them is from easy to more difficult, from elementary to combinational. Okay, so for example, if you start with a very complex test case, when you start with a very complex test case, then most likely you are going to fail. Okay, before you attempt the very simple ones. Okay, so when you fail, then you have to isolate where exactly it failed. Then you have to tune your test and run some other tests, and so maybe running, is this the thing it failed, or this thing it failed, or this thing it failed. So it's kind of like over here. Think of over here. You want to test about the infinite loops and things. Before you test the infinite loops, you want to make sure you can reach some states first, right? If you can't even get into the loop, then you don't even need to bother to test the loop. If it's a dead loop, it's not going to be an infinite loop. Okay, so you have to first test the kind of the states and state coverage, and before you move on to test the loops and things like that. Okay, so there are natural sequences there. They're typically from simpler ones to more complex ones. Okay, and there are also other cases that are other dependencies that you have to test this one first before you can test some other things. Okay, because the other things are a combination of, say, I'm looking at the combination of two things, two modules, how they interface. If I don't know if each module is working itself, then I cannot really testing the interface between those two. Okay, so I can test them individually and then try to put them together. Okay, so there are natural dependencies. There are some natural sequences and dependencies. Okay, and their effectiveness concerns, and so all those concerns will help you have a smooth and effective testing procedure, and make sure you make the best use of your resources and do the best, do the most good within the limited constraints. Okay, but then that's a kind of a procedure preparation. Then with the procedure preparation, we the other part that kind of typically the more time-consuming part is the test case preparation. Okay, and typically people recognize this is something that I need to prepare. I prepare. Okay, so what is a test case? What is a test run? And some of the concepts we need to clarify. Okay, so a test case is basically a description about a more precise description about what will be tested and how it will be tested. Okay, so in a sense is that if you make it precise, you have to look at the object you are testing. Okay, so clearly identify. Okay, my test case is for this object. Okay, and maybe a subpart of this object, or maybe just looking at one flow path through this object. Okay, and then I look at some precise information on how exactly it will be realized. So, for example, if I want to say this one here, go back to this example here. If I want to go from here, eventually reach D, then I need to go from A to B, B to C, C to D, for example. That's one path I want to test. So this is my path I want to test. So this is my path I want to test. If this is the path I want to test, then to enable for me to go from A to B, there must be some condition associated here. From B to C, maybe some condition here. C to D, there may be some condition, and actually this condition is that different from going back to A, different from going back to D. Okay? So I have to satisfy those conditions to go there. And those conditions are typically specified by some associated input for that. Okay? So I need to specify this path and the input for me to realize this path. Okay? So that's basically my test case. Okay? So with my test case, then I will be looking at some input to enable me to do this execution from start, execution to finish, what I intend to test. Okay, so to do that, then I will be looking at, okay, I look at the input. So what is my input variable? What is my input space? Okay, input variable is basically any of the variables, or any of the values that I need to supply. That's my input variable. Okay, and oftentimes when we do the input testing, we also consider constants. Okay, some of the constants need to have pre-assigned values and things. Okay, and then you look at when you look at the input, it's not typically not just one input. Maybe it's multiple input over time. Okay, and so if you look at input X and input Y, then the combination of X, Y give you a point in a two-dimensional space. Okay, so you can look at the input space and look at the input domains, and then we can look at various things such as what we discussed here with the input space and the input domains, and then define those input space and input domains. Okay, and then another related concept is a test run. Okay, a run is basically one execution. Okay, but then it's a kind of too rough a definition, because sometimes you say, oh, a run is one execution, but then if you think of some system is continuously running, a run is one execution, maybe it's too long. Okay, think of an operating system or telecommunication infrastructure system. Okay, then operating system from start run to finish run maybe takes a few months. Okay, so you don't want to have that one as just one test case. You want to divide that into several small chunks. Okay, so oftentimes if you have something running continuously, you have some kind of cutoff from some beginning point to some end point that defined as a run. Okay, so that cutoff point can be just timestamps, or can be associated with some events. Okay, you start some transaction, finish some transaction, maybe that's a run. Okay, so it's just an operational instance that's defined by a complete instance or by a snapshot within a time period with a start point and an end point. So when you're talking about test run, it's a kind of a dynamic entity. When you are talking about the test case, it's a static entity. Okay, and of course, then each test case, when you run it multiple times, you have multiple runs. Okay, and when you have a run that's complicated, and you might want to break it down into multiple test cases, and then you have individual test runs that's related to your original run. Okay, so those are some of the basic thing. And then when your preparation is that you need to prepare the individual test cases, and then you need to prepare them as a collection of test cases. So individual test cases, you will need generally need some kind of model. Okay, so for most of the systematic ones, we will be using some black box model, white box model, usage-based model for testing. Okay, but for the simple ones, sometimes that you can do the record and replay of some of the things, record some of the scenarios and replay it in the testing. Okay, so that is still a viable strategy. Okay, especially if you have some tool support to do some record and replay. And in the testing terminology, once you have a test case and you want to make sure that it will be following that test case, you need to find out the input value, make you follow through with that test case. That step of finding the input value to realize your test case is called test sensitization. You sensitize your test case to make sure that it can be realized. That's called test sensitization. Okay. So later on, as we discuss all the major testing techniques, we'll look at you collect the information, build your model, select what to test, sensitize it, that becomes your test case. Okay. And then you may need to define coverage or usage or some other goals to keep track of those progress. Okay. And then a lot of times we have to construct their models. So we need to collect information, analyze the information, and build a model. So we will talk about those steps in association with the individual testing techniques. Okay, typically, once you have a model, you can derive your test cases from model. How do you do that? We will look at each of the model and how do we derive test cases. Okay, and sometimes those models can help us with the result analysis, reliability analysis, quality analysis as well. Okay, and then with the individual test cases, then you say, okay, another way of looking at it, try to achieve some coverage, try to achieve some completeness, is that you try to have a collection of individual test cases. Okay, so you have to get your so-called test suite to achieve some kind of coverage or usage goals. For example, for the usage goals, you will be looking at something like this. Okay, for usage goals is that, oh, my test suite will consist of maybe 8 samples of this one, and maybe 80 samples of this one sample of this one, 10 samples of this one, and maybe I forget about this one because this will have very low probability. I don't need to care as much. Okay, so that's your test suite. Okay, according to your operational profile. Okay, you can have your test suite according to some coverage. Okay, you can say I have to get one from each subdomain. Okay, so you get your test suite from there. And then maybe you can get a test suite by augmenting existing ones. Say, for example, originally you had a product like this, that's product A, and this is then you get augmented to A prime that added some, extended this one and added some more things that you can handle. Okay, so you can say, I got the original test cases and I add some more to the test cases. And actually, that is an interesting problem in testing. Is typically when we do the so-called regression testing. Regression testing means that we want to, after we add in some new functions to the system, make sure that whatever we kept is still working. Okay. So in this case, is that we need to know what's the difference between the new version and the old version, and then use that information to select some of the old test cases that is still appropriate, and then create some new test cases for the newly developed functions. Okay. So those are some of the test suite preparation considerations. Okay, so you need to construct, and sometimes you can reuse some of the things, and you can manage them by some of the new hierarchy and looking at how many new test cases you need, and how to get those new test cases, and basically try to achieve some kind of coverage or usage considerations. Okay. So we talked about that, and then there is this execution part. Okay. Execution part is actually more straightforward. Okay. So you are running it, you're observing it. The key thing is that when you are running it, you're observing it, you have to distinguish successful versus non-successful runs. Okay. So that determination is in the testing strategy. You have to look at this. You try to start doing this execution, and then try to identify the problems. And the problem identification here, I have the is really looking at the problem identification part is really more of the, say, whether this is expected behavior or unexpected behavior. That is, in the testing terminology, that's called the test oracle. We mentioned about that before. Okay? But when you do it, okay, you need to allocate the time, invoke the test, identify the failures, and collect the failure information. Okay? So when you allocate the time, it's basically according to your usage or coverage criteria. Okay? And you can try to sum up from bottom up, and for individual things you need this much time, so this is for the test suite you need this much time. Okay? And then you can do the execution. Okay? And typically your execution will be based on your precise operational profile or based on your precise test cases. Okay? With the input that you sensitize test. Okay? And oftentimes you need to do the retest to fix the problem. Okay? And so that's a part of the activity as well. Okay? And identify the system failures. Okay? That's really the difficult problem. And that problem is theoretically, you cannot really always tell whether a behavior is expected behavior or not. Okay? It's a kind of like our Turing test or the halting problem. Okay? In the if you have taken the theory of computation problem, okay, the class that you would have encountered this halting problem, and sometimes look at the Turing machine halting problem is basically looking at whether a program will ever terminate. In general, you cannot really determine it. Okay? And in this case, whether a program will always give you the expected result in general forms is an unsolvable problem. Okay? But we do have a lot of help. Oftentimes external help can help us solve this problem. So one of the things that we typically do is to rely on some cross-check. Okay? Cross-check if you have a competitor's product, similar product of different characteristics, you can use that. So for example, we talked about 2 plus 2, the result. I got 5. You know it's a different result than you expected. How do you know? Because you know your addition. Okay? And or because you don't know your addition, but you have a calculator. Okay? Or because you can use Microsoft something there. Okay? And you can use your smartphone, you can use your calculator, you can use you can consult an expert. Okay? You can ask a friend, you can ask a professor, or you can ask someone. So you can have those kind of things to consult. And sometimes even for that you cannot really consult, get the definite answer. So what you can do is that sometimes you do some sampling of internal state. Okay? So for example, that you can have some heuristics. By doing addition, I must be able to call some arithmetic operations there. If all I did is a string operation, probably I'm not so comfortable with it. Okay, I'm doing the addition, numerical computation with all the string operators. Maybe you can do it, but I don't think it's probably the right way to do it. So you can do some of that kind of sampling and get some kind of indication about this. Okay, but in general, it's a kind of hard problem. When we talk about individual testing techniques, we will touch upon the oracle problems a little bit about how do you check the result and how do you check the not only the result is correct, but also is what you are testing that gets the result. So for example, you are testing one path, you actually followed another path that got the correct result. Although the result is correct, that test case is not correct because you didn't test that part you were trying to test. Okay, so that's a kind of additional part of the oracle problem. Okay. And then we have the part of this is the defect handling we talked about. Okay, and you can do the defect measurement. We mentioned about some of the things, and we will be talking about it more later on. Okay. With the analysis and follow-up, essentially what they are trying to do is to try to analyze the problem and try to follow up with whatever their next step is going to be. Okay, so we have seen some of the analysis of the testing data based on their collective data on the cumulative failures and the time, and we fit reliability model. Okay, but for individual level, so this is another important part is that look at the analysis and follow-up. It consists of higher level analysis follow-up and lower level analysis and follow-up. Lower level analysis follow-up is basically dealing with the individual test cases and the test result. Okay, so individual test runs, and you say whether there's a failure. If there's a failure, you do some analysis and find out what's wrong, and then you have this retest, and we will revisit some of that later on. Okay, and then you can look at the overall at the group level, whether that analysis is going to be focusing on how are you progressing against the goal you set in the beginning. Okay, so for example, if you are doing usage-based testing, are you progressing towards your reliability goals or not? How far are you progressing against that reliability goal? Okay. So we'll be looking at that, and then so for example, we talked about this analysis follow-up, different levels, and with some input and output. Okay, and we'll talk about a lot more later on. But the thing is that I want to connect this to your project again. Okay, so for graduate students, you are expected to perform some analysis not only for the individual test runs you perform, individual test cases you run, but also collectively. Okay, overall analysis. Okay, for the undergraduate student, if you only do the thing for the individual cases, that's okay. If you want to go the extra mile doing the collective analysis and follow-up, that's great, but you are really not required to do so, because when you need to do that more in-depth analysis and follow-up, you will need to read a little bit from chapter 19. Okay, and so for the graduate student, I expect that you will be doing some of that. Okay, and we also have the management and automation, some of the issues. I can briefly talk about management, and we can stop there, and I can talk a little bit more about automation issues in the next class. So in terms of management, really the main thing with the test management is really looking at the people's roles and the responsibilities. Okay, essentially, we will be looking at kind of two types of management styles in terms of testing management, because you have many of the activities. Because when you do the testing, there are a lot of knowledge and expertise involved. by the people who are doing the testing, right? And so the knowledge and the expertise can be broadly divided into two areas. One is the testing knowledge, one is the product knowledge, right? So one is how much do you know about the testing techniques and the tools and the testing specific things. Another one is how much you know about the product, right? So if you know more about the product, it's probably better to utilize your knowledge from the beginning of the product to the end of the product, right? And if you know more about testing, maybe it's better to utilize your expertise to perform this thing you are expert on every product, right? So it doesn't matter, so it's a DB2 or it's another compiler or it's something computing supported environment. If you are very good with usage-based testing, you can do usage-based testing for all of them. You are very good at the dependency analysis, you can do dependency analysis for all of them. Okay? So based on that kind of knowledge mix that you have, we have the so-called the overall vertical management style, horizontal management style. Vertical is you follow through. If you have good product knowledge, you can follow through with the product. You can help with the inspection, with the unit testing, with the component testing, system testing, integration testing, and the product release, the final acceptance testing. Okay? And if you are very good with the specific knowledge about testing techniques, then you can perform that testing technique across different products, utilize your expertise. Okay, so that's the two basic management style. But in reality, typically people use a mixture of those things. For example, in IBM, the groups I dealt with, okay, mostly was a system testing group for all the database products. Okay, so they not testing this version of the database for the mainframe, but for workstations, for PCs, and so for all kinds of database products. Okay, so they do have some product knowledge, but they are more specific knowledge is about system testing. So they do the system testing for all this. In a sense, I had more expertise in terms of their overall usage-based testing, operational profiles, and data analysis. So actually, I worked with database people, I worked with the compiler people, and some other people. So I cover more of the product, but at the, not at the deep, at the involved level. So what I did with the different groups is more like this horizontal organization of the testing. And what they did is kind of within their own big functions. But they do have people move from development to help people with testing as the testing build up. So in that sense, they are doing some of the vertical test management as well. Okay. So I'll stop here. Okay. So we still have the test automation question we haven't talked about. Actually, I'm thinking of maybe defer that to after we're talking about all the major testing techniques, okay? And because we'll be talking about specialized testing, and then some of the testing automation tools may be able to fit into there. Okay, so starting next class, we'll go into in-depth discussion about individual testing techniques. Okay, so that's it for today. Okay. Independent verification and validation. So that's basically have some of the third party doing independent testing. Okay, so good night and see you next week. Let me put this up and